Hi everyone, this video will cover vocab from section 1.3 and a few example problems. Please go ahead and write the date that you're watching this video in the upper right hand corner. Take notes as you watch the video and remember to pause when you need to. So this video is about classifying angles. There's a lot of different ways that we can do that. When we're looking at one angle, we typically classify them by their measure. So there's 4 different cases, okay? Acute angles are when an angle measures between 0 degrees and less than 90 degrees. A right angle measures exactly 90 degrees. And remember, when we know that it's an exact 90-degree angle, we go ahead and put a box in the corner. An obtuse angle measures between 90 but less than 180, and a straight angle measures exactly 180 degrees, okay? And a straight angle is going to look like a line. So every line really is a straight angle, okay? When we look at a pair of angles, we can classify them based on their measures together and on their position to one another. So when we're talking about adjacent angles, those are going to be angles that share a side. Okay, so let's see. Let's say that I have 2 angles here. So I have angle 1 and angle 2. And so these angles together share this side in between. So they are adjacent. Non-adjacent angles are angles that do not share a side. This can look a little bit different. So first you could have 2 just completely separate angles, completely separate vertexes, okay? When angles share a vertex, maybe non-adjacent angles will look something like this, okay? So this angle here and this angle here are non-adjacent. And if I were to go ahead and trace over those angles, I see I have this angle here. And let me do this in a different color. Let's see. If I do this angle here, I see that I end up tracing 2 completely separate angles. All they share is that middle vertex, but that's not enough to say that they're adjacent. Okay, complementary angles are 2 angles whose measures add up to exactly 90 degrees. And again, complementary angles can be both adjacent and non-adjacent. So let's say that I have an angle here and an angle here. If this angle measures 35 degrees, I know that its complement would be 55 degrees because 35 plus 55 is, let me double check, yep, that is 90, okay? So that's not adjacent. They can be adjacent though, and oftentimes they'll look something like this, okay? Usually when they are adjacent, we will see that 90-degree angle box in there, but not always. So let's say that this one's 20 and this one is 70 degrees. Now, okay, here's one of our number 1 important things that you're going to hear all year. A lot of times when we're looking at diagrams are not always drawn in the way that they're actually meant to represent. And what I mean here is that if I'm looking at this complementary angle diagram that I drew, I don't actually think that this is 70 degrees or this is 20 degrees and this is 70 degrees, right? Like that is not accurate to real life. So when that happens, we say that the diagram is not drawn to scale. A lot of times in this class, the diagrams will not be true to what they actually look like. Now, sometimes they will, but you have to be able to trust your math instinct and not your eyeballs, okay? Okay, supplementary angles are going to be 2 angles whose measures add up to exactly 180 degrees. And again, they can be adjacent or non-adjacent. So let's say I have this angle here and this angle is 80 degrees. And this angle here is 100. And I know that 80 plus 100 is 180. An example of adjacent angles. So notice I started off by drawing a line. Let's say that this angle is 125 and this angle is 55 because those 2 angles together will add to 180. A linear pair of angles is going to combine 2 words together. So a linear pair contain 2 adjacent angles and their measures add to exactly 180 degrees. So these angles, linear pairs, are both adjacent and supplementary. Okay, and for our diagram, we've actually already drawn that. This diagram that we drew here, the 2 adjacent supplementary angles, is our example of a linear pair, okay? But a linear pair of angles, and I might make a note here, these are really any 2 angles that form a straight line together. Okay, last way that we can classify a pair of angles is a vertical pair of angles. And so vertical pairs come when we have two lines that cross over each other. Okay, so maybe I have a line here and I have another line here. Okay, and they can cross at any angle measure. But vertical angles are two angles that are directly across from each other and they have congruent measures. So for example here, let's switch colors. If I look at this angle in here, its vertical pair is the one that is directly across from it, this one here, okay? And vertical angles are always going to have the same measure. So if this measures 63 degrees, you can bet that this angle also measures 63. Now, one thing to note is that when you have vertical angles, the other angle pair that's next to it is also going to be vertical. So this angle here and this angle here are also vertical as well. So you always end up with two vertical pairs. All right, when you're ready, go ahead and we're going to flip over to our next page. We're going to look very briefly at a couple examples, okay? This first example, we're going to use this diagram to identify the following angles. So go ahead and if you need to pause the video, look at this diagram and kind of take it all in, okay? I notice here that I have some different points. I have point A, B, C, D, and E, and then this O point here represents that intersection of all the lines. Okay, so first up, we're going to identify two complementary angles. So remember, complementary angles are two angles that add to 90 degrees. Okay. So there's a lot of different answers to this question, so I want you to think about what some other possible alternates could be. We're only going to do one example in this video. So I'm looking just for two angles that add to 90. Well, I know that 27 and 63 add to 90, so I'm going to go ahead and name those angles, okay? And remember, when we name angles, especially because they're all kind of smushed together, we have to use the three letters. So the 27 angle is going to be angle BOC. And the 63 angle is going to be COD. Okay, next up we are going to look at some supplementary angles. So remember, supplementary angles are angles that add to 180 degrees. So you just need to find two measures that add to 180. Again, lots of answers, but I'm looking specifically at the 63 and the 117, right? So let's go ahead and name those angles. So angle, let's see, AOE and angle EOD. Okay. Now, next up, a linear pair. So remember, a linear pair of angles are going to add to 180 and they have to be adjacent, which means that they have to share a side. So I actually think that our example for supplementary angles will also work for the linear pair because I see that they share that side in between them. So I'm just going to go ahead and draw an arrow. But there is another linear pair in there, so I want you to think about what that would be. Okay, vertical angles. We are looking for two angles that they have the same measure and they're going to be formed when two lines cross. So first of all, I see the 63 and 63. Those are congruent. Let's just make sure that they're formed by two lines. So I see we have this line here and we have this line here. So that is where two lines cross. So those are vertical. So we have angle AOE and we have angle COD. Okay, adjacent angles, we're looking for two angles that share a side. We already did one with the linear pair, but let's get a little fancier, okay? Just any two angles. So, I don't know. Let's maybe do AOB and BOC, right? Because they share this side in between. All right, and then last up we have non-adjacent angles. And those are two angles that don't share a side. So we just need to identify two angles that don't have any side in between them. So if we're looking at AOB again, maybe I'll choose COD because they have this gap in between. All right. Again, remember, many answers. Think about some other alternate answers for this question. I do want to take a look just briefly at question number 2. And this question, again, we are going to use this diagram to answer it. So first, for part A, we're going to identify the linear pairs, and there could be multiple, that include angle 1, okay? So angle 1 is this angle here. So we're trying to find all of the other angles that are a linear pair. And remember, a linear pair shares a side. And I know that they're going to add to 180 degrees, but here, when we're looking at this 1, 2, 3, 4, that's not talking about the measure. That's actually another way that we can name angles and kind of tell them apart from one another. So we don't know their measure, but remember, linear pairs, what's kind of the base word of that? Line. We're looking for two angles that share a side and form a line. Okay, so with that, I see that angle 1 and angle 2 share a side and form a line. So I'll write angle 1 and angle 2. And I see that angle 1 and angle 4 also do the same thing. So those are our linear pairs that include angle 1. Next up, we're going to identify all of the vertical angles. Well, there's a lot in here, okay? So I'm going to only give you one, and I want you to think about the rest of them. So for instance, I see that angle 2 and angle 4 are vertical angles, I should say. Okay, so for this question, why don't you go ahead and find the others, and we'll talk about that in class. Okay, and then question 2C, it says, are angle 6 and angle 7 a linear pair? So here's angle 6, here's angle 7. I'm not going to answer that in this video. I want you to go ahead and think about this one as well, and we'll answer this in class. Okay, that's all for this video, everyone. I will see y'all later.